basically what we're doing is we're taking multiple ways to manufacture and combining it in a box. We're taking traditional machining with metal, we're taking additive manufacturing, also known as 3D printing with plastic, and a little bit of welding, and we're bringing it together to serve more than one purpose.
We were able to finally successfully test a 3D printed metal impeller fan in an assault breaching vehicle, which is a variation on the M1A1 Abrams. The vehicle went out, and I actually got some time playing in the dirt, kicking up debris, and proving that the impeller fan was doing its job, removing that debris from the air filter. Right now, if you need this part, you have to wait months to get it, pay over $1,500. What we're trying to do here, the time it takes to go from I need it to I have it, can be a matter of days instead of months.
So with the van axial fan, also known as the impeller fan for the M1A1, that was a complex project, but we approached it from two different standpoints. We tried to replicate it from nothing, as in we took a pair of calipers, a trained eye, and we took measurements and we input it into the computer-aided design program. We were able to print one out of plastic and run it on the tank engine. We wanted to ensure that we had the most accurate product we were putting out there. So we took the metal fan, we sent it out to get laser scanned for accuracy. We took that file back, ensured that it was in compliance with form, fit, and function, and then we sent it out to get metal 3D printed. Not too distant in the future, we're going to be able to laser scan it ourselves for complex features such as the fan. We'll be able to also metal print it in-house, and we'll do everything here, which will then shorten the time it takes to get a product in and to push a good product out.
It's been exceptional performance, and they've had a vision and a thought on where they wanted to go, and they put it out there, and they moved toward that together as a team. And it brought a lot of people into this, and they came up with a really nice outcome here. So they have had strong performance, just kind of with a good vision and a good approach, unified throughout the command. And so it's been really neat to see kind of an idea come all the way to fruition to kind of deployment. Sergeant Schneider kind of came up with this design. She's had some help with some of her more experienced Marines, and they came up with a solution to a problem that has plagued the Marine Corps in a lot of areas.
One of the biggest challenges would be knowledge. We attended SolidWorks training classes in San Diego, and those do help a lot. It's a perishable trait, so the more you work at it, hopefully the better you can get. Take the part that needs to be replicated into the X-Man trailer, where we'll start on the computer and we'll start using SolidWorks to design and measure and replicate our product here. So once we take the measurements, we go ahead and try to replicate it here, which is SolidWorks, do our final layering. So this is what's going to then be able to send it to the computer, and it will show you each tool path that it's going to go. So then from there, save it again, and you're able to send your part to the control center. Control center is just placement for the printer, so this is the printing bed, essentially. And from there, it shows you how much model material, how much support material, and how much time it's going to take you to print it. And then from there, you're able to print the job.
I see that 3D printing is a way of the future, but it's always going to be necessary to have a machinist there to get those specs. The 3D printing is never going to get it exactly on point, and there's also always going to have to be some type of post-processing, which is going to require machining.
So this project, this has gone on for months, and the reason for that, it's new field, it's new territory that we're trying to explore. If we look back and analyze all the lessons we've learned, and we were to get a new project, similar to what we've done now, we would cut that time to a fraction of what it would take to accomplish all that. But because we had to work together and we had to work with outside entities, there was a lot of lessons learned. It was all new territories for all of us.
It's extremely significant. This is going to be one of the first metal pieces that has successfully gone through this process. This has proven a concept that has been a goal of Commandant for a couple of years now, to get metal printing to actually start solving supply issues, delays in the supply chain, and readiness problems.
It took a lot of time, a lot of hours. Every person that's with this program, they weren't voluntold to be a part of this program. They volunteered, and everybody had something to contribute. And in the beginning, they had to do their main jobs, and the X-Man was a side hobby. So all the hours that were put in on their own time as they could fit it in. And this project alone, with everybody involved, has thousands of hours adding up to what it is now. And we couldn't have done a better job. But as we move forward and we get better machines, and as we learn from the lessons, we're going to get more efficient, and we're going to be able to turn out better projects.
I think that what the Marines really focused on is they always kind of had that innovative spirit. And when you can get the technology in the hands of the Marines, and you give them a little bit of training, and you give them a little bit of a vision on what you're trying to do, they will do amazing things. It's a case study, it's a glimpse into what's in the realm of possible.
What we've accomplished with the X-Man so far is, as you would say, the tip of the iceberg. We've done so much with so little that there's so much more just waiting to be seen. As we bring out this next variation of the X-Man and we go out to more field ops and we show its capability, it's going to be felt all over the place with what we're going to accomplish.